If you were to look at a single block of red clay under a high-powered microscope, you would see a chaotic and beautiful universe of iron oxide, crystalline quartz, and interlocking organic fibers. To the average traveler, it is just common dirt, the kind of dust that coats your boots after a day in the desert. But 16 centuries ago, on the jagged, sun-bleached edge of the Atlas Mountains, this dirt was transformed into a sophisticated weapon of survival. We are standing before Ait Ben Haddou, a massive, fortified city that glows like a dying ember against the pale, shimmering desert sky. In this region of the world, the sun is not a source of life. It is a relentless and apex predator. The mercury here regularly hits 50 degrees Celsius, or 122 degrees Fahrenheit, near a temperature where the human heart has to work twice as hard just to keep the internal organs from shutting down. Most modern materials would simply buckle under this extreme radiation. Modern concrete would crack, expanding and contracting until it failed, while trapping the heat inside and turning any building into a slow cooking oven. Yet, this ancient red fortress remains as cool as a mountain cave, even in the dead of July. This is not a lucky accident of history or a byproduct of primitive building. This is a masterclass in molecular engineering and passive thermal management. This is the story of the Red Shield. The first secret of Ait Ben Haddou lies in the highly specific chemistry of its soil, a material science perfected over dozens of generations. The master builders did not just use any mud they found beneath their feet. They sought out iron-rich clay from the deep riverbanks of the Unayla Valley, a material that had been filtered by the mountain runoff for thousands of years. When this clay is mixed with a precise and secret ratio of river gravel and hydrated lime, it undergoes a slow but powerful chemical transformation. The iron oxide within the soil acts as a natural binder, a mineral glue that holds the structure together. But more importantly, it creates a specific albedo effect. While we perceive the fortress as deep red, a color we usually associate with warmth and fire, the mineral composition of these walls actually reflects a massive portion of the sun's near-infrared radiation. This is the first layer of the shield. It is a biological and mineral hybrid material that reflects the energy back into space before it can even begin to penetrate the surface of the home. It is a radiant barrier built by hand, using the very minerals that make the desert so hostile. If you find yourself amazed by how our ancestors turned common dirt into high-performance thermal armor, you should consider hitting that subscribe button right now, because we are uncovering the engineering secrets of lost civilizations every single week, and you do not want to miss the next survival masterclass. To build these towering structures, which can reach up to 5 stories high, the ancient Moroccans utilized a high-pressure technique known as pisse. They didn't just stack bricks and wait for them to dry. They built the city in massive, monolithic sections that function as a single unit. But using heavy wooden forms held together with hand-woven ropes, workers would pour in the earth mixture and compress it with rhythmic, synchronized strikes of heavy wooden rammers. This process was often accompanied by chanting, a rhythmic heartbeat that ensured every strike landed with the same force. This mechanical compression eliminates nearly all the air pockets within the wall, creating a density that rivals modern reinforced stone. Because the material is so incredibly dense, it gains a property known as extreme thermal inertia. In a 50-degree summer, a wall of rammed earth that is 1 meter thick creates a temporal barrier between the family and the sun. It doesn't just block the heat, it delays it in time. We call this thermal lag. It takes the energy of the Saharan sun more than 12 hours to vibrate through the molecular thickness of the wall. By the time the peak heat of noon finally reaches the interior rooms, the sun has already disappeared below the horizon, and the desert air has plummeted toward freezing. The fortress then begins to breathe out the day's warmth, protecting the inhabitants from the bitter, bone-chilling cold of the Saharan night. It is a self-powering, stone-based battery that has lasted for over 1,000 years without a single repair to its core. The logistics of moving this much earth were staggering. Think about the sheer volume of material needed to build a fortress that houses hundreds of people. Every kilogram of clay and every liter of water had to be carried by hand or by donkey up the steep slopes of the hill. Or the builders were not just masons. They were master logisticians. They understood the seasonal cycles of the river and the exact moment when the clay had the perfect moisture content for compression. If the soil was too dry, it would not bond. If it was too wet, it would crack during the curing process. They were operating on a margin of error that would terrify a modern civil engineer. This level of dedication to survival is what we explore here on Survival Engineered. If you want to support this deep dive research and help us find more of these hidden engineering marvels, make sure to give this video a like and join our growing community of researchers by subscribing. But the engineering goes much deeper than just the thickness of the walls. Ait Ben Haddou is a vertical labyrinth designed to manipulate the very movement of the air itself, as using the landscape as a fuel-less engine. The city is a dense cluster of towers, separated by narrow, deep alleys called sabbats. These alleys are intentionally designed to be in perpetual shadow, even when the sun is directly overhead. Because the air at the bottom of these narrow, canyon-like corridors is shielded from the sun, it remains dense, heavy, and cool. Meanwhile, the hot air on the rooftops is constantly being swept away by the prevailing desert winds coming off the mountain peaks. This creates a powerful pressure differential that effectively turns the entire city into a giant, silent vacuum. The cool air from the alleys is sucked into the houses through small, high-placed ventilation slits, while the rising heat inside the rooms is exhaled through the rooftop terraces. It is the Venturi effect, utilized at an urban scale. But even when the outside world is a stagnant furnace of 50 degrees, a constant, refreshing draft is being pumped through the red corridors of the fortress. The interior of a Kasbah in Ait Ben Haddou is a study in stratified survival, where every meter of height is a calculated decision. The builders understood that heat rises, so they organized their society vertically to take advantage of the mountain's breath. The lower levels, which are almost entirely windowless and integrated into the bedrock of the hill, function as a massive thermal anchor for the entire structure. This is where the livestock and the massive grain stores are kept. The grain itself acts as a secondary thermal buffer, absorbing any stray heat that might enter through the foundation. The ground itself acts as a heat sink, drawing energy away from the upper living quarters. As you move higher into the private areas, the rooms become lighter and the walls slightly thinner to reduce the weight on the base. But they are always insulated with a secret mixture of chopped straw and sheep wool embedded into the plaster. These organic fibers are more than just stabilizers to prevent cracking. They create millions of microscopic air traps that break the path of thermal conduction. It is a multi-layered defense system, where every floor acts as a thermal shield for the one above it, creating a sanctuary of silence and cool air in a world of noise and fire. The social structure of the city was literally baked into its architecture. The wealthy families lived in the upper rooms where the air was freshest. But even the poorest residents benefited from the collective thermal shield of the neighboring buildings. By packing the houses together, they reduced the surface area exposed to the sun. In Ait Ben Haddou, a single wall often serves as the divider for two different families, effectively halving the thermal load on each room. This is communal engineering at its finest. If you are starting to see that our ancestors were far more advanced than history books suggest, then you belong here with us. Join the thousands of others who are rediscovering these ancient machines by clicking that subscribe button right now. We are just getting started on our journey into the most extreme environments on Earth. One of the most impressive and overlooked feats of the Moroccan engineers was their mastery of moisture in a place where water is more precious than silver. In a desert where it hasn't rained for months, moisture is the difference between a wall that stands and a wall that crumbles into dust under the wind's abrasive power. The towers of Ait Ben Haddou are topped with white crowns of noura, a specialized lime plaster that is almost entirely waterproof and highly reflective. But the clay walls themselves are active and living. During the rare morning mists that roll in from the mountains, the porous red clay absorbs a microscopic amount of water from the air. As the temperature climbs toward 50 degrees, this water begins to evaporate from the surface of the wall. This is adiabatic cooling in its most primal and effective form. The evaporation process consumes a massive amount of thermal energy, effectively chilling the surface of the wall from the outside in. The fortress literally sweats to keep its inhabitants alive, using the very humidity that makes the heat so oppressive to create a cooling effect. The white crowns of noura also served a secondary purpose. They were a beacon for the caravans that traveled the trade routes between the heart of the Sahara and the Atlantic coast. Imagine being a merchant traveling through a 50-degree wasteland for weeks, seeing that shimmering white and red fortress rising on the horizon. It wasn't just a city, it was a promise of life. The noura plaster was made by burning limestone at specific temperatures and mixing it with local minerals to create a surface that was as hard as marble, but could still flex with the movements of the mud walls. This material science allowed the buildings to remain upright during the occasional earthquakes that shake the Atlas region. They had created a structural system that was simultaneously rigid enough to support 5 stories and flexible enough to survive the shifting of the earth. Logistically, the construction of this city was a feat of collective endurance that is hard for our modern, individualistic minds to grasp. Thousands of tons of earth were moved by hand, basket by basket, up the steep and slippery slopes of the hill. They didn't have iron cranes, hydraulic lifts, or heavy machinery, but they had the collective heartbeat of a tribe and an absolute, non-negotiable knowledge of their environment. They knew exactly how much river gravel to add to the clay to prevent it from shrinking and cracking under the lethal sun. They knew that if the foundation was not built on the solid rock of the hill, the desert wind would eventually undercut the walls and cause a catastrophic collapse. It was a construction project that required a vision spanning generations. A wall built today wouldn't be fully cured and at its maximum strength for another 50 years. They were building for a future they would never see, creating a legacy of stone and clay for children who had not yet been born. This is the kind of long-term thinking that our modern world desperately lacks. If you think we need to bring back this kind of sustainable brilliance, let us know in the comments, and make sure you are subscribed so you can be part of the conversation on how we can rebuild our world. The defensive capabilities of Ait Ben Haddou were integrated into its thermal design. The outer wall was not just a barrier against enemies, it was the primary heat shield. By making the perimeter walls exceptionally thick and windowless on the ground floor, they created a solid ring of thermal mass that protected the interior core of the city. Any enemy trying to breach the city would not only have to face the archers in the towers, but also the physical maze of the interior. The streets were designed with sharp, 90-degree turns to prevent a charging enemy from gaining momentum, but these same turns also served to break the flow of hot desert winds, to preventing the streets from becoming wind tunnels for the Sahara's heat. Every corner had a dual purpose. Every stone was a calculated component in a machine of total survival. However, the Red Shield is currently facing a threat that no amount of ancient engineering can solve: the loss of its people. An Earth-built city is a living thing, not a static monument. It requires the constant, loving touch of human hands to maintain the lime wash and to patch the erosion caused by the seasonal sandstorms. If the city becomes a ghost town, a museum for tourists instead of a home for families, the breathing bricks will eventually lose their moisture balance and begin to dissolve back into the Saharan dust. In our modern age, we are obsessed with glass skyscrapers and steel structures that require a constant or violent injection of electricity and refrigerated chemicals to remain habitable. We build glass ovens and then pay a fortune in carbon and cash to cool them down. Ait Ben Haddou shows us a different, more humble path. It shows us that, with a deep understanding of geology, thermodynamics, and the simple, ancient power of the shadow, we can build a world that is not only beautiful, but infinitely sustainable. As the global climate shifts and the 50-degree summers of the Sahara become a reality for more and more of the world, we must look back at the master builders of Morocco with a sense of humility. They proved that the earth beneath our feet is the most sophisticated and resilient building material ever discovered. They proved that you can conquer the sun without burning a single drop of fuel or installing a single sensor. But they built a red shield that has stood for 1,000 years against the most aggressive environment on Earth, and it is still standing today, waiting for us to rediscover its secrets and apply them to our own uncertain future. The preservation of Ait Ben Haddou is now a global mission, but the real secret to its survival isn't found in UNESCO reports. It is found in the few families who still choose to live within its walls, who still understand the rhythm of the clay and the song of the wind. They are the guardians of a technology that we are only just beginning to name with our modern scientific terms. They call it home. We call it a miracle of thermal lag and adiabatic cooling. But regardless of what we call it, the results are the same. A city that refuses to melt. A fortress that refuses to die. A red shield that reminds us of who we once were and who we might need to become once again. Would you be willing to live in a world where your only protection from the sun was a wall of compressed mud and the ancestral memory of the wind? Would you trust the dust of the desert to keep you alive when the horizon is on fire and the air is like a furnace? Let me know in the comments below if you think we have truly advanced as a species, or if we have just forgotten how to listen to the rhythm of the earth. We have so many more stories to tell, so many more ancient secrets to uncover. If you enjoyed this journey into the red heart of Morocco, do not forget to subscribe to Survival Engineered and join our mission to find the machines of the future in the ruins of the past. Your support is what keeps this research alive. Stay curious, stay resilient, and always look for the logic in the stone and the secrets hidden in the red clay. We will see you in the next one as we vanish once again into the Earth's most impossible places.